how this airplane spoke to us!
We are going to dismantle a combat myth. During the height of the air war over Europe, Allied pilots reported something strange happening when they pushed their aircraft into a high-speed dive. They described a piercing, melodic shriek echoing from the wings. Many of those pilots believed this exact machine, the North American P-51 Mustang, possessed a kind of mechanical instinct. They swore the sudden sound acted as a guardian angel, a warning tone that triggered precisely seconds before a German fighter attacked out of the sun. To understand exactly where this noise was coming from, we have to conduct a forensic hairdown of the airframe, starting at the outermost boundary of the metal skin. Before we can look at the physical hardware, we have to map the invisible fluid dynamics occurring across the aircraft's surface. Standard fighter wings designed in the 1930s placed their maximum thickness near the leading edge. The oncoming air would spit over the thick curve and quickly break apart into a rough, turbulent vortex, generating massive aerodynamic drag. The Mustang had to escort heavy bombers all the way to Germany and back. To eliminate the drag that would drain its fuel tanks, aeronautical engineers shifted the thickest point of the wing profile backward, resting exactly in the middle of the chord. Look at this airflow cross-section. The boundary layer of air is able to slide over the skin without separating. It glides like a perfectly smooth sheet of glass, creating an ultra-low resistance state known as laminar flow. Because this slipstream of air was entirely free of rough turbulence, it behaved exactly like a focused jet of air blowing tightly across the top of a woodwind instrument. The polished wing surface didn't make the sound. It supplied the unbroken, high-velocity breath. The air simply needed an opening to blow across and a hollow cavity to resonate within. We locate that cavity by dropping exactly one layer beneath the aluminum, directly into the internal voids at the front of the wings. Mounted deep inside these hollow bays were 6 heavy .50 caliber Browning machine guns. The barrels of these weapons extended forward, passing through open cylindrical holes in the leading edge. As the aircraft accelerated, highly pressurized air rammed straight into these open ports, pouring around the barrels and into the empty space of the weapons bay. The air rapidly compressed inside the wing cavity. Its only exit was a series of narrow shell casing chutes designed to drop empty brass out the bottom of the plane. The air was forced down and ejected through these tiny mechanical slots. At 400 miles per hour, this cycle converted the open gun ports into a set of immense metallic reeds, generating a sharp, high-frequency shriek. But the acoustic profile of the aircraft was not coming from a single location. Far behind the pilot, resting against the lower fuselage, was a massive air intake scoop. This inlet was engineered to catch high-velocity air and use it to regulate the intense heat radiating from the Packard Merlin engine block. This diagram illustrates the air volume moving into that space. The incoming air compresses through the dense cooling fins of the radiator and pushes out a variable flap at the rear. This large, enclosed tunnel of rushing air performed the exact mechanical function of a bass organ pipe. While the wing bays emitted a piercing, high-pitched whistle, the radiator scoop produced a heavy, low-frequency rumble. The functional demands of a long-range fighter perfectly aligned to produce 2 distinct, extreme frequencies at the exact same speed. To figure out how the pilot actually perceived these dual frequencies over the roar of a V-12 engine, we have to examine the connective tissue holding the airframe together. The Mustang relied on a stressed skin configuration. Thin sheets of aircraft-grade aluminum were pulled tightly over an internal skeleton of structural ribs and riveted firmly into place. When the high-pitch frequencies traveling from the wings meet the deep bass rumble vibrating up from the belly scoop, they achieved an acoustic coupling. The energy transferred directly into the metal frame. The thin aluminum panels between the rivets began to vibrate in sympathy with the air pressure. The entire exterior skeleton of the aircraft effectively became a giant acoustic speaker. The vibration traveled from the skin panels, down through the structural ribs, and directly into the cockpit floorboard and seat. For the pilot, the scream was a physical force, transmitted through the metal and felt directly in their bones. The ghost in the machine was an accidental consequence of laminar flow, hollow weapon bays, and raw speed acting on a vibrating metal canvas. But proving the sound was a mechanical accident leaves us with a severe psychological contradiction. If the whistle was just structural vibration, Why did veteran combat pilots routinely rely on it as an instinctual warning system predicting enemy ambushes? To resolve that, we have to step out of the engineering bay and observe the human brain under extreme biological stress. We have to map how the nervous system operates when pulling 6 Gs in a lethal aerial pursuit. In the next chapter of our investigation, we examine the biology of auditory tunneling and how the human mind decodes mechanical sound precisely when a pilot's vision begins to fade to black. Our first investigation mapped the physical mechanics of the Mustang's screaming wings. Now, we find the true impact of that sound in the minds of the young pilots who flew these machines into combat. Across multiple fighter groups, aviators swore the piercing sound was a supernatural sixth sense. They described it as a sentinel shrieking into their headsets at the exact moment they needed to react. This phantom whistle warned of a specific threat, a German Messerschmitt or Focke-Wulf diving out of the blinding sun to execute a high-speed ambush. This creates a logical paradox. How could an aerodynamic sound produced by a pilot's own aircraft foretell the arrival of a hidden external enemy? To solve it, we have to look past aeronautics and examine the terrifying intersection of dogfight geometry and extreme human biology. In the skies over Europe, altitude equaled energy, and energy dictated who survived the encounter. The Luftwaffe utilized boom and zoom, sitting in concealment at 30,000 feet before executing a high-speed ambush. Seeing this, an Allied pilot's reflex was a vertical split-S dive to build evasive speed. This maneuver accelerated the P-51 from 300 to over 450 miles per hour. This 450 mile per hour threshold is the physical trigger for the wing whistle. The sound resulted from the pilot's own defensive maneuver, not a warning of an approaching enemy. Under the stress of a 3-second ambush, the human brain sought patterns where none existed, linking the self-triggered sound as a prophetic warning of the attacker. The phantom whistle stems from the biological trauma of pulling extreme Gs during a high-speed brake. This physical stress triggers a biological defense mechanism known as auditory gating. Extreme gravitational forces pull blood away from the brain and eyes. As peripheral vision fades into tunnel vision, the body shuts down non-essential sensory inputs. In this hyper-alert state, the brain filters out the low-frequency roar of the Merlin engine. High-frequency, piercing sounds operate on a register bypassing this biological block. The metallic whistle from the gun base sliced completely through the pilot's auditory filter. With engine noise suppressed, this sharp sound materialized out of thin air, like an omen of danger. This ghost was a biological illusion. The pilot perceived the aerodynamic scream only once his brain was forced into total combat focus. While the pilot experienced the sound as an internal warning, the battlefield below felt its physical impact. The vibrating wing panels projected a massive acoustic cone forward, alerting ground troops to the Mustang's arrival split seconds before the plane cleared the horizon. German pilots had used mechanical Jericho trumpet sirens on their Stuka dive bombers to intentionally terrorize the ground. The Mustang achieved this through its organic design. This shriek signaled the arrival of a high-speed hunter, turning the Mustang's clean aerodynamics into an instrument of psychological terror for the enemy. Engineers at North American Aviation intended to design the world's most perfect aerodynamic wing, accidentally creating an acoustic alarm system in the process. It was only in the crucible of dogfights that speed, open gun ports, and G-stress fused together to create a legend. This whistle was the true voice of the machine itself. It was an aerodynamic masterpiece crying out at its physical limits, signaling its pilot to survive, fight, and conquer the sky.